Hi, I'm Ken Miller.
And I'm David Erdos.
And welcome to the Erdos Miller New Technology Podcast, where we spend our non-productive time talking about everything drilling tech. David, how you doing?
Good.
You guys have baby number 3 coming soon,
Yep.
right?
Any week now.
So maybe we'll miss you for a couple podcasts in a few weeks.
Yeah.
Okay. Well, congratulations. It's awesome to have that news, right?
Yeah.
So anyways, we're hot off the back of an implementation here. I know the team just recently finished our integration with Micropulse and Babelfish, right?
Yeah.
So that's done and working, and it's going to go downhole here shortly. But wanted to talk about RSS in general, right? Like,
yes.
why did we do all that, right? So
Yeah.
why don't you take us through like the whole spiel here?
Well, why don't you start off by kind of describing an RSS and the difference between different types of RSSs, like push the bit versus point
All
the
right.
bit.
Well, full disclosure, I am not an RSS expert. I'm starting to get a feel for it, but I feel like a complete RSS newbie still, right?
Yeah, me too.
You know, and a shout out to my friend Jeff Lassiter over at Kinetic Upstream. He's a very cool guy. But he told me like the story of how they got started in RSS, and they talked about being in Egypt like 30 years ago or something, and like really struggling against some sort of formation push or something, and being like, well, can't we just like put a sleeve on it and put some weight over here, and it should kind of push back this way or whatever, right?
Yeah.
But the basic idea is we've had the conventional assemblies forever, right? And I think the first way that people figured out how to do it was with just a bent sub, right?
Yeah.
Because no motor or whatever else, just from the surface, you could either rotate it or not and slide. And I mean, not really slide, but push things forward or whatever, right? And then we get into the whole conventional assembly that's lasted forever, right? Which is typically NWD, mud motor with a bent housing, right? And then being able to slide and rotate and control the direction, and that's still the preferred instrument of choice for a lot of people, right? But for the last 25 years-ish, right?
I mean, it's cheap. It gets the job done.
Yeah. Well, actually, I was going to say for the last 25 years, the industry's been developing the rotor steerable technology, right? And so the idea here is instead of having a bend sub, right, we're going to have a bend or a push or a point on demand when we need it, right?
Yeah.
Because the downside of a conventional assembly is you're still making a bigger hole than you might want because you're having to rotate the bend all the time, right? And that makes a bigger hole. So it makes slightly different hole sizes. When you rotate versus when you slide, you have these little kinks that Mr. Ed Stockhausen has been really big about showing people and showing you how you get this kink when you go change between the modes, right? And the idea is like, okay, it'd be nice if the bend just kind of went away when we didn't need it, and then came back when we did need it, right? I know there's all sorts of adjustable housing motors and stuff like that, but I think some of them are even downhole adjustable. I'm not really sure about all that stuff. That's not my area of expertise. But RSS is basically trying to get that, right?
Right.
And so what we're doing is we're putting a tool behind the bit that has the ability to either push or point the bit in a certain direction and get it going in that direction, right? And so usually these are electronically controlled devices, right? Because we need a computer down there to sense what the current state is, sense what it's the difference between what it's doing and what it's supposed to be doing, and then take an action, right?
Yeah.
And so there's usually electronics and batteries and hydraulics and mechanics and motors and everything that goes into building one of these things, right?
Yeah.
And so the basic idea is the push the bit versus the point the bit systems. The point the bit systems are the ones that I'm less familiar with, but the way I understand it is, there's internal mechanics, and what they try to do is they try to have an internal bend or an internal orientation, right? That they can either increase or decrease, and then point the bit in a given direction, as in just get it kind of angled going the direction you want, right?
Yeah.
I think the Vicky is a point the bit. I couldn't even list to you the point the bit systems. That's where I need to go talk to one of my friends, right? But, the push the bit systems I think are a lot more commercially successful, right? Like the auto tracks that push the bit, the power drive / orbit, whatever somebody is calling it these days. That's a push the bit system as well. And those are a bit simpler, right? You see them all the time. They have these big pads on the outside of the RSS, and they actuate and they push really hard against the rock to push the bit where they want to go. And so I know there's a couple of different ways of doing it, and I know that some just there's like rotating versus non-rotating sleeves designs, and the rotating ones try to actuate the pads really, really fast as you spin around, right? And I think the non-rotating ones make it a bit easier on themselves, where they try to have the pads not rotate and then kind of just keep those geostationary and then push in the direction they need to go, right? To some extent, right? Once again, not an expert on the actual systems, right?
Yeah.
But I mean, this is essentially what is a disruptive new steering technology, right? Now, it was new in the 90s, right?
Yeah.
But it's steadily been gaining market share every year, right? I mean, I think RSS accounts for like half of footage right now. It's a huge hot topic. I mean, and I do expect that the RSS systems will continue to gain market share year after year after year, right?
Yeah.
And the great news for this is it doesn't put motors out of business, right? Because we still
Right.
really need a motor. We just need it, back behind the NVD and the RSS to provide the power, right?
Yeah. And that would usually be a straight motor. Right?
Yes, correct, right?
And so like with the RSS, you eliminate that whole lag of like, you have to drill ahead, see what your inclination is. You have to send it to surface. The driller has to then decide whether to slide or to drill ahead. And so the
That's
RSS...
the promise. That's what they're supposed to do. Sometimes they don't quite do that, but that's the idea, right?
Yeah, and so the idea is you program your inclination and azimuth hold, and it just maintains that, right?
Yeah, that is what systems do today. Is they know they can measure inclination, and they know what inclination they're supposed to be at, and they can measure azimuth, and they know what azimuth they're supposed to be at, and they'll say, okay, well I'm at 89 degrees, and inclination, and I'm at 355 azimuth, right? And I'm supposed to be at 90 and 360, right?
Yeah.
So I'm going to push up and to the left, right? To get to where I want to go, and kind of push the opposite way. Push down if I'm going to go up, push left if I want to go right?
Yeah.
And so in self-made systems, right? Or self-guiding systems,
right? So I mean, if the RSS already has accelerometers and maybe probably magnetometers to measure inclination azimuth, why do we even need the MWD?
Okay, well there's answers to that are technical and political, right? So, but before we get into that, let's talk about like what the conventional stack up usually looked like, and then what the RSS stack up looks like, right? So, the conventional stack up is a bit simpler, right? It's NABD and then it's motor, right?
Yeah.
And in this case, the measurements are quite a ways back, right? Because motors can be upwards of like 40 or 45 feet, and then you might have 10 or 15 feet of spacing in the NABD, so your ink and as gamma could be pretty far back there, right? And so that's two-piece assembly, and then everything else in the BHA above that. That's your steering measuring assembly, right? The basics of directional drilling is I got to have something to deflect, and I got to measure that deflection, right?
Right.
And then in the RSS BHA, which I think is like we used to talk about it as the BHA of the future. It's still the BHA of the future because it's going to become more commonly used. But the configuration I prefer and strongly advocate for is RSS on bottom, short as possible, right? Mm-hmm. NWD right above it, right, and then a straight motor behind it, right? And like to me, that's like a trifecta, right? The RSS is doing the best job it can steering. The NWD is in the best position it can be, as far as measuring. It's as close to the bit as reasonably practical, right? And then we're still using all that wonderful power harnessing or power generation of the positive displacement motor, right, to really deliver a lot of power to that assembly, right? And the PDMs are just fantastic for taking that massive amount of horsepower at the surface and then transferring it downhole through the fluid. Those things are awesome and, geometric, like, wonders of the world, right?
Yeah, I love seeing the rotors and the incredible machining and precision.
Yeah, well, and then you have all the new metal on metal ones, which are even cooler now, right?
Yeah.
And so those are all fun, right? So, so your question was, why do I even need the RSS and the NBD, right?
Yeah.
So here's a technical answer. You don't. Right?
Yeah.
But if you have an RSS system that is predominantly non-magnetic, right?
Yeah.
It has high-grade, survey of record grade inclinometers and magnetometers on it, right? And it has a pulsar. There's no technical reason that the rotary steerable system and the NWD system cannot be fused or merged into one unit.
Yeah.
Okay? No technical reason, right?
Right.
Okay. The more practical reasons are usually not entirely non-magnetic, right?
Yeah.
Usually you want to, have some separation there. It's easier to make the RSS out of steel. You want to have some magnetic spacing, so therefore spacing them out makes a bit of difference, right?
Yeah.
Another more practical reason is that, and this is the biggest reason I'm a proponent of the systems potentially staying separate is as far as like getting a team together of brilliant engineers to build really cool things, it's really hard, right?
Yeah.
And getting together a team that can build the best steering unit and the best measuring unit is going to be tough.
Right.
Like there's a lot of knowledge in both sides. There's a lot of history, a lot of existing features to overcome, right? You wouldn't want to have an amazing, RSS with a low quality integrated NWD because that would kind of kneecap the overall system, and vice versa, right?
Right.
And so I think you just, letting the NBD guys build the best system they can in the world, and letting the RSS guys build the best system in the world they can, that's efficient, right?
Yeah.
But nothing stops them from teaming up,
right,
and doing some cool stuff, right?
Yeah.
But like as far as one homegrown team building everything, could happen. It's tough, right?
Right.
The other political reason is that operators might often advocate for and may continue to advocate for wanting to have a separation of responsibility, right?
Yeah.
So, they might want to say, okay, this group that I'm hiring here is responsible for deflection or steering. This group here that I trust, that I've worked with for a long time, I'm going to have them measure the survey of record. I don't want the guys who are steering and measuring to be the same group, right? Like maybe you do, maybe you don't, but that could be a political reason, right?
Yeah, for sure.
So there you go.
Okay.
Yeah.
And so traditionally, does the RSS and MWD talk?
Well, I would say most easily done, they don't.
Yeah.
The easiest thing is just to put them in the ground next to each other and then just not have them talk, right?
Right.
And I've been joking about this with people as we run more and more RSS systems, but it still weirds me out to put a tool in the ground without a tool face in the NBD config.
Yeah.
It freaks me out, right? It's like something's wrong here. Like I know it's right. My logical brain knows it's right.
Yeah.
My emotional look for any sort of discrepancy and destroy it because it's probably going to bite me in the butt.
Yeah.
Gets triggered and it's like, oh my God, there's something wrong with this system configuration or something.
Yeah.
But and why is that? Well, you don't need tool faces anymore, right?
Right.
There's no bin to keep track of. The RSS is doing it all internally. And so the really great thing about RSS systems is it allows us to send more formation and measurement evaluation data because I don't have to send tool faces anymore.
Yeah.
And tool faces used to be a huge bandwidth hog, right?
Yeah.
Like we wanted to have the sliding mode and we wanted that to be mostly tool faces.
Yeah.
But hey, I still want seeing shock and vibe, gamma, all this coming up, right?
Right.
And so, when we run with an RSS, it's just great because we just push the tool faces right out of the sequence and it just gives us so much more data, right? So like that VHA is not only potentially better at steering, but we're making better decisions because we have more data, better data coming off of it, right?
Right.
What was your question?
So are they typically connected? And you answered that question.
No,
so
they're not, right?
What are the benefits of connecting them?
Okay, so we talked earlier about how an RSS, has a programmed inclination and azimuth hold, right?
Right.
And so, or both, or one, or whatever, right? And so, how do you change this, right? Because we're still not at the point where the RSS can know where it is along the trajectory. That'll take a bit more of a sci-fi project, right?
Because it doesn't have depth.
It doesn't have depth, right? It doesn't know the well path. And so it has to just follow the given line that it's been told, or vector that it's been told to drill, right?
Yeah.
And so how do you change that vector? Well, you have the downlink to it, right? Mm-hmm. And so, most RSS systems have some downlinking protocols that you can execute via flow or rotation or whatever, and then get them a new setting, right? Well, if they don't have a pulsar and they're not connected to the NWD, right? Then there's no way for them to confirm or deny, like it's a deposition or something, whether or not, or an interrogatory, that's what they call it in legal terms, confirm or deny whether or not it received the downlink. And if it did, even if it did receive a downlink, what value did it get, right? Because it could have received a downlink, hooray, but oops, I accidentally programmed it for 92 degrees instead of 90, right?
Yeah.
And so when you don't have the easiest way to solve this problem is to connect the RSS via the NBD to the NBD via some data link, such that the RSS, when a downlink is received, can tell the NBD, yes, I got a downlink.
Yeah.
Here's the value I got, and the NBD can use its mud pulse or electromagnetic transmitter to send that to the surface, right?
Okay.
And so that saves you a ton of time, guesswork, wondering, right? Like the guys who really know what they're doing, they can usually get it by. But I mean, every once in a while, you're gonna be like, that thing's drilling at 92 degrees, and I programmed it for 90. I know that's not very good.
That sounds a little scary, not having any feedback.
Is that formation push, or is that that I get the downlink wrong, right?
Yeah.
And so that's the number one reason, right?
Yeah.
Now the second reason is just for which isn't quite enough to justify the link, but real time monitoring of the RSS, right?
Yeah.
What are the parameters? What's the temp, RPMs, vibe that it's seeing? If it has a gamma sensor and it getting that extra information, that's all good stuff, right? The downlink confirmation and then the monitoring of the RSS. Right?
Yeah, I think the downlink confirmation by far is, probably the most important one because otherwise you're kind of doing it blind, which sounds to me really scary. Now maybe the people that run these all the time can pick up on.
No, it is pretty scary.
It's like, How do I know if it's not going to start like drilling off in the wrong direction because it misinterpreted the downlink?
You won't until it does.
Until it does, and then you're kind of in the same problem as the traditional assembly. You're not really. You're gonna go back and forth, and have all these angles in your wellbore.
You could argue that the traditional assemblies don't have this problem because they don't have to send the downlink to change the tool face.
Right. No, it's
points, right.
Right.
I have a constant monitoring of it. Right.
Yeah.
Yeah. So.
And so, but I mean, of course, also you have those sensors much closer to the bit, like inclination, much closer to the bit. Potentially have gamma right there.
To me, we talk about the BHA as a future, like the creme de la creme for me of like most cost-effective, most robust, most valuable is, an RSS that's predominantly non-matic so that we can get inclination and azimuth, and then while drilling, continuous inclination and continuous azimuth at the RSS, plus an azimuthal gamma sensor, add her in the RSS, that is just going to be fantastic. That is going to be such an effective, power punch of economics, right, and measurements.
Yeah.
And so...
And having those measurements that much closer to the bit, even if it's like 10 feet back, it's still not like 60 feet back like it would be in a traditional assembly.
Yeah, I'd love to have the sensors ahead of the bit, but as far as like practical reality goes of like, not having Star Trek style magical sensors that can scan anything they want from any distance, right? That always drove me nuts in Star Trek. I love Star Trek, but like that bothers the heck out of me when it's like, oh, we scanned the planet's surface for life forms, so it's like, how?
Yeah.
Like with what magical sensor did you sense that there's no plutonium on this planet or something, right? Like, anyway, your magical Geiger counters that can sense any amount of radiation from any distance, right?
Yeah. Maybe one day with like some quantum physics magic, we'll see. Probably not.
Okay. Digression alert.
Yeah.
Right? But
okay, so we talked about the importance of connecting the MWD to the RSS, but what are the challenges with that? Why isn't everybody doing it now?
Okay, so the easiest way to do it, the absolute easiest way to do it, is just to wire the RSS and the MWD together and then go from there, right?
Right.
So that's difficult for a couple reasons. One, these things are in different collars, and therefore there's going to be some pretty big tolerance differences or stack-up differences when you go to plug them together, right? So just getting the wires connected up through a connector, getting that sealed, and getting that robust has its own problems, right?
Right.
That's typically approached with a, what's like some sort of telescoping or spring-loaded electrical connector joint, but like those are not trivial to make reliable, right?
Right.
The NWD is very reliable at its interconnects because there's no spring loading, right? Like they're all tight tolerance, good sealing, all this kind of stuff, right? When we go to big tolerance, the sealing becomes an issue, wires become an issue, connectors become an issue, rig side assembly becomes an issue. That's difficult, right? That's not the biggest challenge. Really, the biggest challenge, this is a controversial opinion that I have, is that there's no good top mount pulsar on the market, right? Why would you need a top mount pulsar, right? So the problem is with the bottom mount pulsars, which are the absolute most popular pulsar in North America, right?
Yeah.
Most anybody who's running mud pulse runs a bottom mount style pulsar. They are very, very difficult to get a wire through, right?
Yeah.
Like just mechanically, the way they've been designed, there's not a lot of room to try and put a wire groove or something else like that. It's very difficult to engineer them in such a way that you can get a wire through them. And on top of that, you'd have all the telescoping problems anyways, right? And so that's kind of a no-go. I haven't seen any good designs arise for that. So if you switch your NWD to using a top mount pulsar and then do a wired interconnect on the bottom, that gets a lot easier, right? But the problem is you can't really go and get, a good top mount yet. There's a number of groups that are working on them, and they're in R&D, and they're not finished yet, or they're in field testing. Like there's not a great one that you can go and buy today and just run, right?
Yeah.
And I think the top mount pulsar guys have a big challenge ahead of them, right? Because the bottom mount pulsars are so far ahead in terms of R&D, research and development, reliability, sustaining engineering, all this kind of stuff, right? That even if you built a great top mount pulsar, by comparison, it's not going to seem that great, right? Because unless you've run your top mount pulsar for 1 billion hours, like the bottom mount pulsars inevitably have, it's going to be really, really hard to compete, right? And so that's almost like it almost kind of feels like a game that's going to be hard to win or you can't win.
Yeah,
right?
I mean, there's just been so much optimization put into the current bottom mount designs.
There's been hundreds of designs. Dozens of engineering groups have tackled this problem. any group that's been running for 10 years has 10 years of sustaining engineering built into their pulsers, right? Like it's really almost an insurmountable challenge, right? To just replace bottom mount pulsers, right? You'd have to have something like, someone would have to come out with like a top mount siren that was just as reliable as the bottom mounts to just start replacing all of them, right? And so, I mean, the way that I advocate for, and the other way to get around this problem is you build a wireless interconnect, right?
Yeah.
And so what you do is, I mean, we can call it a short hop. When we're transferring data less than 10 feet, I prefer to call it a micro hop.
Yeah.
Personally, just to convey the short distance, right?
Right.
But if we have a wireless transmitter at the top of the RSS and near the bottom of the NWD, right, then we can just basically, the RSS company can do their job, the NWD company can do their job, we can show up on location, they connect together, and then off you go, right?
Yeah.
And so, our team just finished the integration with the Babelfish, right?
Right.
And so Schlumberger's system is pretty cool. It has a built-in wireless system to it, right? So you just have to plug in their wireless receiver to your NWD, right? And so that's how they're getting that done, right? And so I strongly advocate. I think overall the wireless systems will be easier. Is easier to build. It will ultimately be more reliable than any sort of interconnected system, right?
Yeah.
And so that's a huge advantage. Yep.
Yeah. No. I mean, you definitely don't have all the issues with the wash and like the sealing you mentioned and the telescoping type connectors.
Totally. Now that just works for Schlumberger's, and there's gonna have to be other solutions for everybody else's RSS, right? But like that's the way I see this going, right? Is RSS wirelessly connected to the NWD motor on top, and that gives you everything you want, right? So that's just really cool.
Yeah, and so I mean, one of the you mentioned the difficulty of getting a wire through, which when I first heard about that problem, I was like, why, about connecting RSS.
It can't be that big of a deal.
Can't be that big a deal. Just get a wire through. But looking at the mechanical design, it's like this is nearly impossible. I mean, or highly impractical.
It could still be done. I mean, I know there's some old GE designs. Like I think the old Centerfire tool has some sort of wire through design like that for the resistivity tool. I mean, it can be done, but can it be done to meet today's reliability expectations? That's where I get a bit more skeptical, right? And that's where I think that just wireless is a bit easier, right? So, but yeah, I mean, I would say that that's the rough state of NWD to RSS, integration today, right? Like wireless is the way to go. Put the NWD above the RSS.
Yeah.
Orbit's got it down. A lot of other groups are working on it, right?
Yeah.
To make sure that everybody's RSS can do this, right? And honestly, I'm just excited. Like it's gonna be a really fun future. And I know there's a lot of really cool RSS systems coming to the market. We just met with the DTech guys. They're very cool. The Sparrow Technology guys out of Canada have a brand new RSS that is coming out. That's very awesome. Our friends at Kinetic upstream have been working really hard on a very innovative design that they're working on. And so a lot of newcomers are entering the market. And so I think there's going to be one of those guys or multiple that win and kind of expand the RSS market share. So I think that's coming, and I think the need for wireless interconnects is going to become more and more common, right? So
yeah, I mean, especially as RSS gains more market share. I mean, is there anybody out there currently other than Schlumberger that has like a good wireless connection to the MWD?
I'm not sure yet. I mean, not that it's public. I know the AutoTrack has their own, right? But that integrates with the Baker systems and all that kind of stuff, as far as I've heard, right? But I haven't seen anything else that's just ready to go, working out there right now, and that's a lot of it's in development, right?
So I mean, that could really be a tipping point for RSS adoption of more readily available options.
It will be required for RSS adoption for sure. The bigger challenge the RSS companies have in front of them is actually getting their RSS to work, which is
fair enough. And price, maybe.
It sounds like I'm being mean, but it's a big challenge. It's a really big challenge. Like building an RSS is no joke. If you're in the middle of that challenge, I salute you, because that is a great undertaking. It's one of the more complicated devices humanity's ever created. And good luck to you.
Yeah.
So awesome. All
right,
Dave. I think I've talked out on RSS today. What other questions can we wrap up with, or good for today?
I think we're good.
All right. Awesome.
Right. So that's all the time we have for today. Thank you for listening. I'm David Erdos.
I'm Ken Miller.
If you like our podcast, please like and